The background to this is I've made my layout 3 times so far, and each time the track's changed. I've had a train going round. I've got 13 points, and I've got no wiring at all other than the electrics to power the loco. So, and each time when I came to start wiring up the points, I've got solenoid, Pico solenoid motors with the piano rod, the long one from underneath. And I just, yeah, I failed every time. So, yeah, on the last occasion, I took it apart and decided to move where I was going to put it anyway to make it easier. And then I joined MERG, and I've discovered this thing called CBUS, and I discovered that you can use JMRI and you can automate things. And I'm a programmer, so that seems to make sense to me. So where I've got to with this is, instead of having a fairly, well, for me, largest layout, it's N scale, so there's cramming quite a lot into a small space, but I wanted to do a really simple layout to the effect where it's just an oval with a loco running round, but that loco being automated, with a single siding off that leads to an ingle nut sidings, so I can do some shunting operations. And that's about it for the layout. I'm not interested in doing scenery, because I started doing the scenery first on my previous layouts because I enjoy doing scenery and buildings and things, but I really want to just concentrate on getting the track and the electrics and the computing side of things sorted out, so I can master it, or at least, you know, learn what I need to know in order to then move on to my bigger layout. So I want this layout to be as simple as possible, an oval with a siding and inlet sidings. I want it to include as many things as I can without making it too complicated. So I'm thinking I want point motors. I'd like decouplers for the shunting operations. I'd like track detection, so that if my shunter comes out of the siding onto the main loop, the automated train that's going around will automatically stop. I did have in mind that I wanted to do signals. I want all the point motors to be using servos. I did think about doing signals operated with a servo, and my N scale semaphore signal arrived Friday, and it's absolutely tiny. And I don't know whether I've got the skill yet to stick a rod onto that so that so I can attach it to a servo. It's absolutely tiny. So I don't know about signals. I might skip that bit in terms of simplicity. But if I'm controlling a servo, I'll be doing that for the point motors anyway. So yeah, the aim of it is that at the end of it, I'll know what I'm doing and be able to happily, with confidence, go and make a bigger layout and expand on it. So there's 2 things really that I want out of this. Is one's a shopping list, which MERG kits to buy, because there seem to be some that, you know, multiple kits that do similar things. Some are older, some are newer. So it's exactly a complete list of all the electronic components and the wires and whatever else I need to go with it. And then I was looking at the automation SIG. Saw a video on that the other week, and the chap was using rock rail. And previously to this, I'd only considered, because it's the only thing I'd heard of, was using JMRI. So now I've got a question in my head, is whether to use rock rail or JMRI. So I don't know whether that impacts on any of the MERG kits, or whether the MERG kits are agnostic about which language we use. Or anyone who's got any ideas about any of these kind of things. So I think that sort of sums up, hopefully that's getting everyone understanding of what I want to do. And at the end of it, I wouldn't mind having, putting it together as a beginner's pack, if you like, which is just a list of, here's your shopping list, these are all the things you need. If you're doing it in Engage like myself, here's a list of the track components and what potential locos and wagons you could pick, and maybe something similar for the 00 gauge, but the electronic side of things would all be the same. So, you know, just here's a list of all the things you need to buy in order to build this layout, and this is how you do it.
Arising from last Sunday's talk, that's the list that I gleaned from it. They wanted the traction to be based on MERG gear. The points, I wasn't sure at that time whether the signals are meant to be semaphore or just lights, detectors, uncouplers, and they did mention trying to control it via a tablet or a phone as a possibility. So that was the kind of starting point. I said, my job isn't to advocate CBUS. I'm very much in favour of horses for courses. If you want to have automation and you want to have tablet control and so on, then CBUS is definitely the way to go. If you look for something simpler, then EasyBus and peer-to-peer light are the way to go. But we're looking today at what's available if you want to go down the CBUS route. So from a traction point of view, you have to have what they call a command station. The one at the top is the module that lets you send the DCC signals to the track. But it has to be controlled in some way. So at the bottom, there's one option to control it via another module called the CANHC. It's just, that's it there, that's its size. Only really get two connections, apart from power that is. The USB cable goes in here, connects to your computer, and at this end, you take the two wires out to control the CAN command station. So that's all to it. A little PCB with a bunch of components. So that's one option. If you do it that way, that allows you, of course, to control it via computer. Because if that's going to the computer, then the software can make the loco go back and forward, stop, reverse, all that kind of stuff. If you don't want to control it via computer, you can use a DCC command station with a handset, another kit you can build, and it connects straight into the CAN command. A lot of good things are said about it. The only downside to it, it's for beginners, is it's surface mount components. So that's all you need to know about traction. Two options mainly. If you want to go down the software route of controlling it, as Phil had mentioned, there is Rockrail, which is compatible with MERG components. And even if you don't want to have automation, you can use it to control it from your screen. You can still pick locos and make them go forward, backwards, stop, and so on. Choose different locos just from your mouse, but with manual control. Or you could, it's got the option to then add on later if you wanted to, a phone or a tablet and so on. So it's got that facility in the software. Or, as Phil mentioned, there's also JMRI, which is also MERG compatible. You just choose MERG as the interface when you're setting it up. And it's also got a bit of software that you can control from the glass screen, as they call it, right, the glass panel, or from a phone. So both of them allow computer operation from the mouse or from a mobile of some description, a tablet or a phone. Now, MERG has brought out this beginners pack, or packs plural, I'm not convinced. Well, let's discuss it. It's a fairly recent innovation. Two packs, pack A, pack B. Pack A contains all you need to do to this is not for traction, this is for accessories and so on. Two main modules and a power supply. And that's fine. You can't control it via a computer that way. It's just that's a physical setup. In that respect, it's very similar to doing something with peer-to-peer light. Or you can add on another pack, pack B, which is a strange mix in my opinion. It does have the CAN USB 4. In other words, that's a computer connection. So now, if you buy those two packs together, then you can use your computer here to control the output from the CANHC 8, which gives you 8 digital outputs. But also in that pack, you're paying for a CANHC 5, which in fact runs tortoise motors. And if you ain't got tortoise motors, I'm not sure why you're paying that amount of money. All of these modules in pack A and pack B tend to come from the older CBUS modules that have been updated. Pack A is all you need to control up to 8 devices from 8 inputs. One of them is called the CANHC, which is that one. Again, you've got 8 digital inputs here. Could be switches, could be push buttons, could be totties, whatever. And then it feeds out to the bus itself, the CBUS. And it's configured with lots of little dip switches to set it up. So you've got that, which is 8 inputs. And then you've got that one, which is 8 outputs, which is that one. So it's working in reverse. That one there, there's got 8 inputs, feeds to the bus. That one's got the bus coming in and feeds to 8 outputs. So you throw a switch at that end, something will change at that end. It's all digital in, digital out. The CANHC 8. It's long in the tooth. You'll see there a starter CBUS project. The starter pack is quite new. The documentation, I wrote that in 2009. So if you want to look at the 13 years ago journals, you'll see exactly step-by-step instructions, not necessarily for the construction, but for the configuration, how to wire them together to get various effects and how to set the dip switches, all that kind of stuff. So all that's available if you want to go down the starter pack route. Because Phil mentioned using points and controlled by servos. And the problem with the CANHC 8 is that these outputs are digital. They won't control the point directly. You can throw a switch on your control panel or touch a button and push a mouse somewhere, but what's going to happen, what's going to come out of these are just between high and low, which won't switch a point. So you'd have to put on a servo 4 board, or you'd have to put on an easy points board. So if you wanted to have easy points, for example, you need to have 8 different modules and that. So you've got 9 different modules to operate 8 points. Or if you went down the servo 4 route, you'd have to have this main module followed by 2 servo 4s. These are 3 big modules to operate 8 servos. Instead, you can buy a module called the CAN servo. And as you can see, it's already got down here, there's the 8 sets of pins that you can plug the servo straight into. And now you can give commands via your software to operate a particular servo. It comes in on the CBUS. decoded from these chips, and then we'll send out the appropriate commands to operate the servers. I think that's probably a more appropriate one to be looking at for the points and semaphore arms. You should be aware there's a whole range of other ones, but from what Phil was saying, I don't think we want to go down this route. The CAN-VOUT is more or less the combination of the 8C, the combination of these two, an 8 input and an 8 output. Imagine those two in the same module. Then what you've got is the CAN-VOUT, which can handle 8 inputs and 8 outputs on the one board. But again, it's digital outputs, what handles servos. Phil said he didn't want to have a mimic panel, a control panel. But if you did, you can buy CAN-PAN to do that. CAN-panel, in other words. Or you can buy one called CAN-MIO, which you can set up with additional software to be either digital outputs or handle servos. And for completeness, CAN-SOL for 4 solenoids. I don't think any of these are of interest to what Phil's looking at. All he needs is a CAN servo and the USB controller, CAN USB. When it comes to uncouplers, there's a case there, depending on what kind of coupler type. Is it the type that needs magnets to uncouple? Is it the type that needs a ramp to uncouple? And there's decisions about whether you push a button for manual control. You position the train over the ramp, and you manually push the button to bring the ramp up or the magnet up to magnetically uncouple. If you want to go down the automatic route, then as Phil correctly said, you need to have some kind of train detectors, some kind of totty. There's two that we sell. There's one that detects current in a section of track, but that's not good enough because you need a spot detection. You need to know that the train's exactly over that point where you want to decouple. So you can't use a DCC totty. You'd have to use something like the one above, the LDR totty, the light detector, or better still, the laser. So you break the laser beam so you know exactly where your train is and the wagons are at any one point in time. And at that point, you can raise the ramp. Now, when it comes to further help and support, there's a whole range of things I want to finish with, because this isn't meant to be the definitive solution for the two fields. It's meant to be a starting point to things to look at. There are courses, as you can see there, how to use GMRI. MERG tends to favour GMRI in most of its training material, although we have got members who use RockRail. So if you wanted to, you can enroll for 6 different courses. So they can be quite expensive, but they are hands-on. So you get lots of personalised help if you go to one of these courses. Or you can go on to the website and download a document for FLIM. I should have mentioned that when I showed you this, I did point out that they're little dip switches, and you have to set them all up to do what you want. You don't require a computer if you're doing this system. And it's called the simple layout system. No computer involved, just lots of setting up, pressing buttons and pulling switches and so on. If you want the computerized version, you can use the FLIM model, the full layout model. There's a full document that works its way through how to configure modules. So there's quite a bit of help there. If you go into the MERG website, there's a knowledge base. And the knowledge base that you can see has loads and loads of different areas that will point you to what the kits do, frequently asked questions and so on, reference material, technical bulletins. previous discussions on it, help on how to build layouts, how to use solenoids and servos and signaling, all that kind of stuff, how to make control panels. There's a huge amount of stuff in there on the CBUS Central, they call it, a section of our knowledge base on the national website. There's also technical bulletins, they call them. If you look at the national website and go into the section called technical bulletins, you'll find lots of information about individual modules, what the CANHC 8 is capable of doing, what the solenoid one is capable of doing. There's ones for interfacing with the Pi, all that kind of stuff, the CANHC 5, the CAN LED, the CAN Servo 8. You can actually read up on them there. And I think lastly, if you go into MERG TV, you can look for a section on CBUS. And what you're looking at there is all the discussions that people have had on using CBUS, their experiences, talks at various area groups. So between all of these, there's quite a bit of material. And of course, not forgetting that the MERG National Forum is just full of material. If you look at any one week or any one day of the National Forum, there's loads of questions from beginners and developers, all talking about, how do you do this? How do you tweak that? What's wrong with that? Why am I getting that effect? There's lots and lots of backup help. So for somebody that's beginning, there's a load of stuff to look at. There's a load of stuff to read. There's lots of places you can go to get your questions answered.
Well, unlike the other Phil, I've decided to go straight in with no test track, and I'm designing the layout I want and trying to learn what I need to know as I go along. I've made a very short video to show where I'm at the moment, and I apologize for the sound quality, but I'll just share that now if that's okay. Main tracks, green, yellow and blue. This is a diagram of my layout. As you can see, there are 3 main tracks, green, yellow and blue. The green track is the only one I'm working on at present, and this will be a commuting. It's my intention to run this circuit as a fully automated loop with 2 locomotives and 2 stations, one at the top being a 2-platform station and the one directly opposite would be a single platform. I want the locomotives to both run at random intervals from either or both stations with the computer controlling this. The other 2 circuits, the main ones, will be done at a later point. One track will probably be a goods track, whilst the yellow tracks will be both a station and my fiddle yard rather than a passenger line. I would like to add a traditional manual switched mimic board to control the points in the station area, but with the facility to add computer control should I wish it. Moving to a video representation of what you've just seen. We're looking here at the station area with the lower platform, the lower commuter circuit. The other circuits will run at the level where the brown wooden line is. This is the location for the second station. This is the commuter circuit and which is operated by a linear actuator, which you can see here. This rises up to full height to allow me easy access, and is also wide enough to allow me easy access with a wheelchair in the future, should I need it. Wall mounting the monitor with the keyboard and mouse living in this little drawer, which further extends to house all of the control equipment which I'm in the process of building. And it's cleverly dissolved into a nice little diagram. I would be very happy to receive any comments or advice on my proposed. That was my little presentation. As you can see, my intention is to use Rockrail as my computer control bit. So that's my little update of where I'm at so far.